let's go to analysis. Okay, we want to perform nodal analysis, flow curve. Okay, so yeah, the outlet node, okay, the wellhead pressure 144.7, and the bottom node is at the reservoir depth, whereas the solution node is at the pump intake pressure, ESP. Okay, set range. Change it to AOF. I want to construct from 1% AOF to 99% AOF. Steps 10. Okay, auto range. And you can also click OK, apply and calculate. Okay, so you get the IPR. Okay, IPR, the nodal analysis, the IPR and VLP. So this is the IPR and this is the VLP. So you get the operating condition is this one. Okay, operating pressure. This is the solution at ESP depth, 689.10 PSIA with liquid rate of 2,318. With water cut of 99%, you get oil rate only 23 stock tank barrel per day. And you get this water rate and gas rate as well. At the sand face depth, at the perforation depth, the bottom hole, you also get the calculated bottom hole pressure of 744.76. And you can also check the ESP performance. Okay. We are currently operating here, right? Okay, so you can see. All right. So this one is the IPR. Okay. Yeah, mainly showing the flow rate. Okay. And yeah, this one is the pump horsepower. You can see the value here on the right axis. Okay. This one is the head. You can see here. Okay. So the values will be made gray on the right, so you can focus on the left vertical axis. Okay, for the head, and this one for the pump horsepower, also for the head. Okay, so wellbore equipment profile, starting from the reservoir pressure here. This is the bottom hole pressure, this is the pump intake pressure, this is the pump discharge pressure, and this is the wellhead pressure, outlet pressure. And this is the temperature profile. Okay, so far so good, and we are currently under 60 Hertz operating frequency. ESP gasiness, no free gas effect. We are currently at this position. Okay, so that's for the introduction. That's our initial condition before adding a new reservoir zone for commingle production. Okay, so what we need to do is like this. So currently we construct the reservoir performance curve based on empirical data. I mean, based on the measurement, based on the well test. Okay. If you want to add a layer, a new layer, you can click this one. Okay. But you will also describe the performance of the new layer using also the test data. Like you can see, we have three options. You input layer parameters, or you input manually, or you input based on well test data. Okay. All right. Either you input manually, just straight inputting the productivity index, or you input the well test data, or you input layer parameters. Okay, because I now select test data, if I add a new layer like this, I also need to provide well test data. But of course I cannot, because it's a new zone. Okay, it's a new zone. I don't know the performance. I haven't opened the well, I haven't opened the reservoir, so I have no well test data. Okay, so of course I cannot predict the reservoir performance of the commingle production, okay, using test data to construct my IPR. I cannot. So what I'm going to do is I go back to the existing reservoir, okay, this one, and I need to change the IPR calculation, okay, from test data to theoretical one, which is the layer parameters. Okay, I need to input, so I just go directly here.